Question number 6. Determine the fractional change in volume as the pressure of the atmosphere, which is 1.01 into 10 to the power 5 Pascal, around a metal block is reduced to 0 by placing the block in vacuum. The bulk modulus for the block is 1.25 into 10 to the power 11 Newton per meter square. Now here you have to calculate the value of fractional change in volume. That means you have to determine delta V upon V, right? And we know that bulk modulus K is equal to P divided by delta V by V. So from here, delta V upon V is equal to P by K. And here the given data are given P is equal to 1.01 into 10 to the power 5 Pascal, and 1 Pascal means 1 Newton per meter square. That means this is 1.01 into 10 to the power 5 Newton per meter square, and K of that block is 1.25 into 10 to the power 11 Newton per meter square. So after substituting the value, it would be 1.01 into 10 to the power 5 divided by 1.25 into 10 to the power 11, and it is 8 into 10 to the power minus 7. So since this is a ratio of the volumes here, so we'll be getting 8 into 10 to the power minus 7. So the answer is this. Question number 7. Find the density of metal under a pressure of 20,000 Newton per centimeter square. Given density of the metal is equal to 11 gram per centimeter cube. Bulk modulus of the metal is 8 into 10 to the power 9 Newton per meter square. Okay. So we can assume that means the initial pressure, which is 20,000 Newton per centimeter square. Then we have the density of that metal is rho is 11 gram per centimeter cube, and we are assuming that the initial volume of that metal is V. Volume is V. And from the bulk modulus concept, we know that bulk modulus K is equal to P divided by delta V upon V. So from here, we can calculate the change in volume, which is delta V. So PV by K. And here K is also given, which is K is equal to 8 into 10 to the power 9 Newton per meter square. Okay. Now here this P is in Newton per centimeter square. So we have to convert this Newton per centimeter square in Newton per meter square, right? So for that, we know that 1 centimeter is equal to 10 to the power minus 2. So 1 centimeter is equal to 10 to the power minus 2 meter. So 1 centimeter square is equal to 10 to the power minus 2 square meter square. That means this is 10 to the power minus 4 meter square. So this would be 20,000 divided by 10 to the power minus 4 Newton per meter square. So which is equal to 2 into 10 to the power 8 Newton per meter square. Right? Okay. So just substitute the value of P, V and K. So P is 2 into 10 to the power 8. V is V. K is given, which is 8 into 10 to the power 9. So 8 into 10 to the power 9. Okay. So from here, this delta V would be Vy 40. Okay. Now we know the change in volume, and we have assumed that the initial volume of that metal is V. So the final volume would be, let us suppose the final volume is V dash. So this would be V minus delta V. So V is V minus delta V is V upon 40. So V dash is 39 V by 40, right? And we know that mass is always constant, right? So mass is constant. So the initial mass is equal to the final mass. That means V into rho is equal to V dash into rho dash. So here rho dash is basically the final density of that metal, which we have to calculate here. So from here rho dash is equal to V into rho divided by V dashed. Okay, now we know V is V dashed is 39V by 40 and rho is 11 gram per centimeter cube. So after calculating this, V will cancel out with each other. We'll be getting 40 by 39 into 11, which is equal to 11.28 gram per centimeter cube. So this is our answer. So the density of the metal under a pressure of 20,000 is this 11.28 gram per centimeter cube. Question number 8. The compressibility of water is 4 into 10 to the power minus 5 per unit atmospheric pressure. What will be the decrease in volume of 100 centimeter cube of water under pressure of 100 atmosphere? Okay. Now compressibility is basically reciprocal of bulk modulus. So compressibility is equal to 1 upon bulk modulus, which is 1 upon K. So from here K would be 1 upon compressibility, which is the value is 4 into 10 to the power minus 5. That is equal to 0.25 into 10 to the power 5 atmosphere. Now volume is given, V is equal to 100 centimeter cube. So 1 centimeter is equal to 10 to the power minus 2 meter. So 100 centimeter cube would be 10 to the power minus 6 meter cube, which is equal to 10 to the power minus 4 meter cube. Then another data which is given, that is P, pressure is equal to 100 atm, which is equal to 100 into 1.013 into 10 to the power 5 Newton per meter square, which is equal to 1.013 into 10 to the power 7 Newton per meter square. Here also we have to convert this atm into Newton per meter square. So this is 0.25 into 10 to the power 5 into 1.013 into 10 to the power 5 Newton per meter square. So here we have the value of K, we have the value of volume, we have the value of P. So from the formula we know that K is equal to P divided by delta V by V. So from here delta V is equal to PV by K. So P is 1.013 into 10 to the power 7, V is 10 to the power minus 4 and K is 0.25 into 10 to the power 5 into 1.013 into 10 to the power 5. So this is basically 10 to the power 10. So we can write here, this is 10 to the power 10. And after calculating this, we'll be getting that 0.4 into 10 to the power minus 6 meter cube. So the answer is, so the decrease in volume of 100 centimeter cube of water under pressure of 100 atmosphere would be 0.6 into 10 to the power minus 6 meter cube. Question number 9. On taking a solid ball of rubber from the surface to the bottom of a lake of 180 meter depth, the reduction of the ball is 0.1%. The density of the water of the lake is 1 into 10 to the power 3 kg per meter cube. Determine the value of the bulk modulus of elasticity of rubber. Take G is equal to 10 meter per second square. Okay. So first, the height of that lake is, or depth is 180 meter. The reduction of the ball is, that means they're talking about volume strain. So volume strain means delta V upon V is equal to 0.1%. The density of the water is given, that is 1 into 10 to the power 3 kg per meter cube. We have to calculate the value of the bulk modulus of elasticity of rubber. So we know that K, which is bulk modulus, is equal to P upon delta V by V. Now from here we have to calculate P first, right? So we know that pressure P is equal to H rho G. This is a formula, and from here H is 180 meter, rho is 1 into 10 to the power 3, and G is 10 meter per second square. So this is equal to 1.8 into 10 to the power 6 Newton per meter square. Now we have all the data here. So P is 1.8 into 10 to the power 6, and delta V upon V is equal to 0.1 percentage. That means this is equal to 0.1 divided by 100, which is equal to 10 to the power minus 3, right? So we have delta V upon V, which is 10 to the power minus 3 here. Now just substitute the value of this here. So it is, now the final answer will be 1.8 into 10 to the power 6. This would be plus 3. That means this is 1.8 into 10 to the power 9 Newton per meter square. This is our answer. So the bulk modulus of elasticity of rubber is 1.8 into 10 to the power 9 Newton per meter square. Question number 10. A uniform pressure P is exerted on all sides of a solid cube at temperature T degrees Celsius. By what amount should the temperature of the cube be raised in order to bring its volume back to the volume it had before the pressure was applied, if the bulk modulus and coefficient of volume expansion of the material are K and gamma respectively? So first, assuming that the raise in temperature is delta T. Okay. Now from thermal expansion theory, we know that volume expansion, suppose delta V is the volume expansion, is directly proportional to the original volume, the coefficient of the volume expansion, and delta T, which is the raise in temperature. So this is our equation, the equation of the volume expansion. This equation is very much important here. Okay. So from here we can write that delta V upon V is equal to gamma into delta T, right? Now bulk modulus K is equal to P upon delta V by V. Now P is uniform pressure and delta V upon V is gamma delta T, right? So from here delta T is equal to P by gamma into K. So this is our answer. So by P by gamma K amount should be the temperature of the cube be raised in order to bring its volume back to the volume it had before the pressure was applied. So this is the answer. So delta T is equal to P by gamma into K.